Hello everyone, this is Ziyuan Sang, and I have two partners. One is the Chris Courier and one is Jacob Walter. For our topic for the project 2, which is circuit analysis, we all want to get an electrical engineering major, so this is the best for us. The math lab is important for the engineer, and the circuit is necessary for the electrical. Let's see what kind of question we have to do today. So we are giving this the circuit diagram to analyze them and to figure out each individual question. At first part, we have to get all the value for I1, I2, I3, R1, R2, R3, V1, and V2. In their circuit diagram, okay, let's see here. First, this one is the first loop. This part the second loop. And this is a big loop for the whole thing. We pick the direction from here and then go like this. Direction go like this on this part. Because the direction for the current I2 is same as the direction we picked, so the whole part for I2 and R2 will become the negative and keep going like this. The direction for I3 is still same as we picked. So the I3 and R3 will be negative also. Until this part ends, we have the first function equation like the V2 minus I2 times R2 minus I3 times R3 equals 0, like this. I2 times R2 plus I3 times R3 equals V2. Okay, for this part, we go from direction like this. Okay, the current one still have the same direction as we picked. So for I1 times R1 is the negative. We have to put a negative sign here. And for this, I3, the still same direction. So I3 and R3 have to be negative sign also. The whole thing for this loop, V1 minus I1 times R1 minus I3 times R3 equals 0 also. For the big whole loop, if we go like this way, the V2, because over here, the direction goes here from here. This side is positive, this side negative. So this side to V2 minus V1. And for here, the direction is current to I2 is same as direction we picked. So this part is have to be I2, negative I2 times R2. Keep going like this. And this part, because the current direction is different the direction we picked, so this I1 times R1 is be positive. So totally whole thing like this. V2 equals I2 times R2 minus V1 minus I1 times R1. And for the junction rule here, the junction at this point, I2 plus I1 plus I2 equals I3. That's the formula. Totally use the whole thing formula. We go to the main script to set up for couple function. First function is a VR function. We got V1, V2, R1, R2, R3. Oh, of course, at the beginning we have housekeeping command CLC, clear all, clear, and close all. And then for the VR part, we set the function equal for those function equals VR, and then get the individual specific data and value for them. And for the second function, circuit silver, I1, I2, I3, minimum voltage, maximum voltage, for resistor minimum voltage, for resistor maximum voltage. Okay, and the first question, it asks us to output those 8 values in this matrix form. So according to by this formula, we set at the equation. We set at the function page like this. I3 equals this, I2 equals this, I1 equals this. This function we all could drive from the 4 function I just showed, and then totally we got the individual this, and we have the value for the V1, R1, and V1, R1, R2, R3, and the V2. We have the value for this. It's easy to get I1, I2, I3. So we just out fprintf the circuit analysis fprintf ng3031 fprintf the numbers or group elements name and data, the voltage with a unit, resistor with unit, current with unit, and then output the each individual values. And then because we need one blank for space, one blank space, so we put a couple more T's here and then put R3 and I3. Let's run the code one time to see what the output looks like. Wow, nice! That is what we want. One space here and the value for voltage, value for resistor, value for current. That's for the first question. We're done. Let's see for the second one. What the second question asks about? To find each individual, to find the maximum and the minimum limit for the voltage Q, and we have to remember one thing, that we don't allow the negative current V1, R1, R2, R3 are still same as this part. So V1, R1, R2, R3 still same as this part. Let's go to the, let me see the function page. Okay. In that word, because V1, R1, R2, R3, V2, they doesn't change at all. Yeah, according to the first equation, that means I3 still same, doesn't change. So far we are not sure for the value about I1 and I2. We have to use this to get the maximum voltage and the minimum voltage. Okay, at the beginning, we change the variable name. Change the C2 to I2. Change the V2 to the minimum voltage 2. Okay, use the while loop. C2 greater than 0. That means I2 greater than 0. C2 equals the I minimum voltage 2 minus I3 times R3 over R2. The equation is still the same as the before we used here. Just the variable name is changed. So. But because for the information and the diagram, we are not sure for the certain number for the voltage and the current, the I2, the C2. So any number suitable for them is allowed. Just remember, the C2 cannot be negative. So each time when the number is suitable for the function, we make the minimum weight. We make the variable voltage minus a little bit. Keep going minus a little bit. I3, R3, R2 still keep the same. So when the voltage 2 this decreased, the C2 will decrease also. After the moment the C2 keep decrease becomes the negative number, the whole program had to be stopped. At this moment, for this part, the voltage is, we got the voltage we want, but this voltage is still minus the 0.01. We have to get the original voltage we want, so we add 0.01. This is for the part we want for the minimum voltage. For the same idea for the maximum minimum voltage also. Let's see. D2. We change the variable name. D2 still I2. I1 still is D2, and the voltage becomes the maximum V2. Still the same formula, and the new formula will drive the formula function. Let's say this I3, R3, they are same. R2 is still same. The D2 we don't know. V2 we don't know. D1 we don't know. V2 we don't know. But I2, R2, R3 we already know that. For this part, if each time the V2 gonna increase by a little bit, so when this rest is keeping unchanged. So when the V2 is keep going, the D2 will keep going. If D2 keep going, the whole thing will if D2 become bigger, and this will become, the V2 become bigger, D2 become bigger. But for this part, because the V2 just become bigger a little bit, each time we just add 0.01 each time. But for this, D2 if become bigger, and it's always multiplied by the R3, R2 and R3. So the amount of is changed is much bigger than the amount of this changed. This one increased more, this one increased less. So it's so fast, it's so easy to get. Just when it become larger and larger, when this minus this equal negative number, the whole program gonna stop, because we don't want D1 become negative. So when it becomes so large, so that means at this moment when the program stop, the voltage is already big enough. That's a big maximum we want. But according to our function, the maximum still at the 0.01. So after the while loop, we have to minus 0.01 to get the real value which we desire to get. So this part is for to find the minimum voltage and the maximum voltage. Let's run for the code. Oh, sorry, what is happened here? Oh, sorry, this is the function page. I'm not suitable to run from here. I should run from here. Circuit analysis. The main script. Let's see. Okay, what we could get. Oh, the maximum voltage is 16.470. Minimum voltage is 5.780. Alright, we got the same question down. Let's see the last one. Okay, it asks the range. We set the range for the resistor from between the 15 to 115 ohms, and we have to figure it out when the range for the domain for the resistor changed. What's gonna happen to the minimum voltage for V2 and the maximum voltage for V2? If the resistor 3 changed, this value be changed also? Let's go. So according to this, we go over reviewed this for function again, and we analyzed for the relationship between the V2 and R3. We set up the function. My friend set up the function like this. My group member, they all set up the function like the I2 equals V1 time multiplied by X. Oh, at the beginning, they set the resistor changed by voltage it's equal to the empty. It's equal to empty. For X equals 1, comma 1 to 150. Be honest, in my opinion, I think for here, begin from 15 and comma 1 and 150 is better, because the domain set is 15 to 150, not from 1. But it's all group code. I keep it the original. I keep the original code because it's done by our total. It's our group coding. So we keep it like same. Make it keep going, and we change the variable name. We drive this function, and then with the G2, we still don't want the negative current, so we keep it like this. After we drive out this function, to say for this part, of course, for denominator, x times x minus R2 plus x times the R1 plus x. No doubt, R2 and R1 is positive value. R2 and R1 is positive value, and z plus x plus x minus this. No doubt, obviously, it's gonna become negative. And this part is become at the beginning is negative value also. V1 is less than V2. X is less than R1 plus x. But when the function keep going, the x will increase. X gonna increase, but R2, the voltage gonna begin to decrease. When the voltage decrease really small, make the V1 times the x is greater than the voltage 2 times R1 plus x. At this moment, this minus this will become the positive number. When it becomes positive number, this minus this is always negative. No doubt this part what's gonna happen. Oh, so this part is positive, this part is negative. The whole thing will become negative. That means I2 is negative. When the I2 becomes negative number, the whole programming for the while loop